Hi guys, in this project let's see how we can create a smile detection program with Python and OpenCV. The first thing you need to do is to download the necessary files. I have given the link below this video. You need to go to the link and download the file. The files are stored in DLU uploader. They may show you some pop-ups. Don't worry, just close the pop-up and you pressing the download button. Once you downloaded the file successfully, let's begin. Open Python IDE, file new, and you need to create a project folder. I am giving the name smile detection. You can give your own name. And I am saving this Python script inside that folder. Call the OpenCV library by typing import cv2. Once you've done that, go to the download folder, extract the file you just downloaded. In that folder, you can see 5 different files. One is an XML file, 2 Python scripts, a test image, and a text file. You need to copy the har cascade smile XML file and the test image to your project folder. Once that's done, let us use that XML file in our project. Now let's import the contents in that XML file to our Python script. For that we are using the function cv2.cascadeClassifier. This will import the data in that XML file to a variable. I am calling the variable as det. Now let's load our test image using the function cv2.imread. This will read the test image into a variable which I named as image. This readed image will save into the variable as a color image. In order to work cv2, not only cv2 but any other image processing project, you need to convert any kind of image file which is in color format into a grayscale image. Here also we need to do that. For that we are using the function cv2.cvtcolor. And this is the syntax for that function. We are using BGR scheme, not RGB scheme. Once this line execute, the color image stored in the variable image will get converted to a grayscale image and it will get stored in the variable gray. Now let us detect the smile in our test image. For that we are using the variable det which holds the har cascade XML file data along with a function called detect multiscale. It will detect our required feature, facial feature in the image, and it will return some coordinates, some x and y coordinates along with the height and width of the feature into our defined variable. Here I am using the variable named smiles, and once this line of code execute, the smiles variable will contain initial x-axis value, initial y-axis value, width of the feature, height of the feature. Here in our case, width of the smile portion and height of the smile portion. Once we get these coordinates, we can highlight it using a rectangle. In order to do that, I am using a for loop to draw a rectangle around the smiling area. This is the syntax for loop in Python. Now to draw a rectangle, we are using the function called cv2.rectangle and provide the image along with initial x and y axis value, which is simply x and y, and final x and y coordinates. The final x axis value is the initial x axis value plus the width of the portion, and final y axis value is the initial y axis value plus height of the smile portion. And I want to display the rectangle in green color, so I am giving the value 0, 255, 0. As I mentioned earlier, we are using BGR scheme, not conventional RGB scheme. The first value represents blue color, second value represents green color, and third value represents red color. The maximum value for a color is 255. 3 is the thickness of the line. Once this is done, all we need to do is to display our modified image in a window. For that, we are using the function cv2.imshow window name, comma, image file. This will display the image in a new window. And finally, we need to give some delay in order to work cv2 properly. For that, there is a function called cv2.waitKey to give delay in milliseconds. Here I am giving a 1 millisecond of delay. That's all. Save the program. Click run module. S letter in the word scale should be capital. So you need to look out for such errors while writing a Python script. Let us run this code again. You can see that our program executed successfully. The smiling portion in our test image is identified and highlighted. Now let us look at the Python script in our downloaded file, smile detection user function. In this script, we used the same code as I explained till now, but inside a user-defined function. This is my user-defined function, face detect custom. Whenever I want to detect a smile from the image, all I need to do is to call the function and pass the image file name to this function. The function will do the rest for me. Additionally, I added a while loop. The code will execute continuously until an exit condition is met. Whenever I press the X button after calling the function, the program will exit from the while loop and ultimately from the user-defined function after displaying a string and closing all the windows. Let us run this code again. You can see the same result. This method is useful if you are writing longer codes that not just involve smile detection.